Um, this one, number one, is my favorite, but I want you to start it, your axes down here. I don't know if you noticed how many sevens there are in this set of data. There's a lot of sevens. And then when you're doing a dot plot, you want the axis to be evenly spaced. So I like to use the spots on the ruler. So I'm gonna mark it every centimeter. I think I did too much, but that's fine because it only goes 4 through 7, but that's okay. So I just drew a line and then I used the centimeter markings to make my axis evenly spaced. And I'm just gonna start 2, 3, 4, 5, 6, 7, 8. The 2, 3, and 8 are really kind of just extra at this point. And then we want to make sure to label our axis. Now, again, for the dot plot, I like my dots to be evenly spaced. So now what I'm going to do is I'm going to take my ruler and put it sideways. And I'm going to put my dots at the half centimeters. So I notice I have 1, 2, 3 fours. 1, 2, 3. I have 1, 2, 3, 4 fives. 1, 2, 3, 4. Mine are kind of going up weird. Okay, I have 1, 6. I can just eyeball that guy right there. And then I have 1, 2, 3, 4, 5, 6, 7, 8 sevens. Yikes. Okay. 1, 2, 3, 4, 5, 6, 7, 8. And that is the best problem of all time, and it is done. I like it. Mhm. Okay, that's the easy one of the two we're doing today. Okay, now we're gonna do the box and whisker plot. First thing we need to do is put them in order from least to greatest. So go ahead and work on that. Okay, these are the 5 things that you need to make a box and whisker plot. Oh, okay. I hope so. Okay, now how many numbers are in this data set? I think it's 16. 16? Okay, so the min is easy to see, that's 20.5. The max is easy to see, that's 43.6. Okay, and since there's 16 numbers, the median is going to be right here. It's going to be in between number 8 and number 9. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Okay, so the median is going to be 27.9 plus 30.6 divided by 2. Which is 29.25. Okay, let me pause there. Are there any questions about how I got the median? Okay, now to get quartile 1, I ignore everything above the median and I find the median of these. So since there's 8 numbers, 1, 2, 3, 4, it's going to be right here. What number is in between these two? Do we need to do an average or can you do it in your head? 25.4, beautiful. Okay, and then quartile 3 will be in between these two. What's in between 34.5 and 36.5? 35 point. Okay, so now we have the information we need to make the box plot and use the ruler again. I'm gonna go every half centimeter. That's plenty. And since the lowest one is 20.5, I'm gonna start at 20 and then I'm gonna go by twos. 22, 24, 26, 28, 32. I don't need to go that far. Label my axes. Okay, so 20.5 would be right here. 25.4 would be right here-ish. 29.25 would be like right before the 30. 35.5 would be right before the 36. 43.6 would be right before the 44-ish. These are going to be estimates. It's okay. We got box and whisk. Okay. You're done with warm-ups and you're done with your packet. You can scooch that off to the side and grab your notebook. And this is going to take you a minute to set up, so take your time. By the way, if you're wondering what this says, this says typo. It's CPM trying not to get sued and saying typo because they don't want Apple to sue them, so they made it typo to be funny. And that's his laptop. Dang, I wish I had a typo. What? Oh, thanks. Is it wrong on the stamp sheet too? I wonder if last year it was on the 17th and I just cheated off of last year's. Let's see. Hmm. Oh, indeed. Look at this. Last year's notebook. Wow. Okay, now does anybody know what the name is of this type of picture right here? That's Venn diagram, yeah. This is called a Venn diagram. We use them in stats. I have to be honest, my students don't love them. So most of the time we convert them to a two-way table, which is what we're gonna do in this class, because I think Venn diagrams are much harder than two-way tables. If you don't know what a two-way table is, just hold on a minute. Let me just make sure everybody's got it situated before I review the ebook problem. Okay, here we go. Sam is conducting a survey for the school newspaper. He surveyed 175 students at his school and found that 28 students had a new Pi phone, 44 students had a laptop computer, and 110 students had neither. Draw a Venn diagram to represent this data and use the information given to figure out how many students are represented in each region. Okay, so I'm going to start with the 175. I like to start with the total every time. And when you have a Venn diagram, you want to put the total right underneath the outside. So I'm going to say total equals 175 students. This helps me realize that all four of these regions should add up to be 175. Can you guys see that there are four regions? 1, 2, 3, and then the outside 4. Okay, next. He found that 28 students had the new Pi phone, 44 had a laptop, and 110 had neither. The next one I'm going to do is the neither, and I'm going to put that right here. This outside part represents how many don't have either what. Poor sad students. No Pi phone, no laptop. So sad. Okay, so here's my next question. If there's a total of 175 students and 110 have neither, what should these three regions add up to? 65. Okay, so they told us in the problem that 28 have the Pi phone. Notice I'm not putting 28 over here, and I'm not doing that for a reason, so hold that thought. 44 have a laptop. That adds up to 72, not 65. What can I determine from that information? No. Some have both. How many have both? 7. 7 have both. And the both section is right here where the two circles overlap. Okay, now we're going to use C to figure out what goes in both of these spots, because this is not 28 and this is not 44. This is 21. That means that this whole circle needs to add up to 28. And this whole circle needs to add up to 44. Okay, so now we're going to check our work. We're going to see if it actually adds up. 21 plus 7 plus 37 plus 110. So that's the kids with only a Pi phone. That's the kids, the super lucky kids that have both. These are the ones with only a laptop. And this is the poor, poor, sweet kids that have nothing, which would have been me. Yup. Right here, the problem said 110 students had neither, so I put that outside. Okay, now we're going to do the same thing, but I want you to draw this instead. This is a two-way table. And I feel like most of my students really prefer this over the Venn diagram. Okay, now we're going to read the problem again. Same exact problem. I know it says number 2. We're going to read the exact same problem, and we're going to figure out how to fill out the two-way table from that information instead of the Venn diagram. Okay, so it says, Sam is conducting a survey for the school newspaper. He surveyed 175 students at his school. When you're doing a two-way table, the total goes down here in this corner, which is very similar to the Venn diagram. I'm going to refer to this as total, all chapter. I'm going to call that number the total. Mm-hmm. Double total. Okay. He found that 28 students had a new Pi phone. Okay, so what you do is you say total Pi phone is 28. So this is the total. This is total Pi phone. He found 44 students had a laptop. That's total laptop. Total laptop goes under here. And then what was the other bit of information they gave us in the problem? 110 had neither, and that goes in the no laptop, no Pi phone box. Okay, now if you guys have a different color on, you get it out because this is the original problem. And then what we have to do is subtract to find the rest of the numbers. So I'm going to say 175 minus 28 is 147. So if 28 students had a Pi phone, that means 147 students did not have a Pi phone. I'm going to do 175 minus 44. That gives me all the students that did not have a laptop. And then I'm going to do 131 minus 110. So this box has to be 21. What does this box have to be? 7. And what does this box have to be? 37. And then do we have now the same exact information we have in the Venn diagram? I think it's easier. You like that better? And you can choose. It doesn't matter. Mm-hmm. Are you sure? Okay, so these two have to add to that. 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 And these two have to add to that. And that's how you can kind of check. Okay. So B asked, how can you check your work? The row totals have to add to the total, and the column totals have to add to the total. So it's very easy to check. The hardest part about it is deciphering the original problem and where to put the numbers in the out of the problem, not necessarily just subtracting. Okay. Now for D, you're supposed to say which one you like better. So your choices are Venn diagram or two-way table. You must choose which one you like better. It's an opinion question. It's not anything for us to do. You guys just say. Okay. Now we're going to talk about the mathematical definition of and or. So and means that they have to happen at the same time. How many students have a Pi phone and a laptop? 7. Okay. And I need to introduce you to this P in the front. This is a new thing for us. We haven't done a lot of this before. This P in the front with the parentheses, you say to yourself probability of. So the big P is probability. And because we're too lazy to write the word probability repeatedly. So when you say P of this, so you say probability of iPhone and laptop. Okay, so when you do probability problems, it's what you're looking for over the total. What's the total number of students in this one? 175. So the probability of a student owning both is 7 out of 175. No, not a big probability at all. 7 divided by 175. Okay, so we're going to write this two ways. We're going to write it as a decimal and then as a percentage. It's really important to me that you guys know how to go back and forth between fraction, decimal, and percent. You were supposed to write which one you preferred, the two-way table or the Venn diagram. It's different for everybody. Okay, now this is not usually challenging for people. This is very specific math definition for or. Math definition for or means you have one, you have the other, or you have both. This represents 3 squares up here. This is where they have both. This is where they have a laptop but don't have the Pi phone. They got some other kind of phone or something. Then this represents where they have the Pi phone but they don't have a laptop. Yes, 65. 60, is it 65? 7 plus 37 plus, hold on. Okay, so next to my little arrow, I added shaded just so that you guys can see back up where I got those numbers from for or. I really want to make sure that you guys understand if you go to the store to buy a Pepsi or a Coke, if you come back with a Pepsi, are you okay? Yeah. If you come back with a Coke, are you okay? Yeah. If you come back with a Pepsi and a Coke, are you okay? Yeah. Yeah. It means that you got one or the other. It satisfies one or the other if you got both. You're just extra lucky. Okay, let me ask you this. If I ask you if you have a dog or a cat, and you have a dog, would you say yes? If I ask you if you have a cat, would you say yes? I'm saying, let's just say that you have a dog. Okay, let's say you have a cat. Okay, and then let's say you have both a dog and a cat. And I say, if you have a dog or a cat, would you say yes or no? Yes, yeah. So they still count if you have both. You're just extra lucky. I don't know if you're extra lucky to have a dog and a cat. I'm not a cat person, but I have a cat because the other members of my family like cats. Yes, honey,
They have a dog and a dog.
but no cat. I have 3 dogs. Don't recommend. See, what happened was I had 2 dogs, and then I moved in with my husband who has a dog and a cat. Now we have the Humane Society for some reason at our home.
Okay.
A lot of hair. Okay, anyway. Number 3. Is there an association between owning a laptop and owning a Pi phone? Meaning, are you more likely to own one or the other? And we're going to ask this in 2 ways. We're going to say, what's the probability that a laptop owner has a Pi phone? And we're going to also ask, what's the probability that a non-laptop owner has a Pi phone? That's not supposed to have a space. It's fine. And we're just going to see if there's any difference between owning a Pi phone if you own a laptop or if you don't. Mike? That's because maybe you couldn't hear me. I said you were supposed to put which one you prefer, Venn diagram or two-way table. Did you pick one? Mike? Did you pick one? Which one did you pick?
I'm not sure.
Do you like them both or hate them both?
No, I'm not sure.
Yeah. I'm a two-way table gal. Okay, anyway. So these are the 2 questions that we're going to ask ourselves. So we need to go back into the two-way table or the Venn diagram. I'm going to do it from the two-way table and figure out what's the probability that a laptop owner has a Pi phone and what's the probability that a non-laptop owner has a Pi phone and see if they're the same probability. Okay, so I'm going to go back up here. I'm going to scroll up. Guys. And I'm going to grab a Post-it note. This is going to be my best way of doing this is to use a Post-it note. And I'm going to say, okay, what's the probability a laptop owner has a Pi phone? I'm just going to limit my view of the two-way table to only laptops people. This is the column that represents people that own a laptop. Okay, how many of those people own a Pi phone? 7. And how many total people have a laptop? 44. Okay, so there's a 16% probability that somebody with a laptop owns a Pi phone. Do you guys know what I'm going to do next? Yeah, I'm going to scooch over my Post-it note, maybe. He doesn't want to lay flat. That's fine. Okay, now, how many non-laptop owners have a Pi phone? 21, right? Because it's no laptop, but yes, Pi phone right there. 21 out of how many do not have a laptop? Yes, 131. Okay, so 21 over 131 is 0.16 or 16%. Okay, so are you more likely to own a Pi phone whether or not you own a laptop? No. All right, you have one more problem. And this one is going to be our notes for two-way tables. Is anybody still writing? No? Okay. Okay, so this is what we're gonna do. Yeah, yeah. Okay, so that's correct. So this is about a PE class, I believe, and they're going to talk about boys that have an A in the class and girls that have an A in the class. Okay, so what we're gonna do is I'm gonna put the problem up. The hardest part about these is figuring out where to put the numbers from the original problem. I want you guys to take 30 to 45 seconds to read the problem, try to figure out what the numbers show. You might want to write them lightly because we might need to fix them. So see if you can do it. If you can't, I totally get it because we just started working on this. But if you can, that means you've already figured out the hardest part. Okay, so it's right here. There are 145 students enrolled at a senior level fitness class at Cooper High School, 116 boys and 29 girls. 24 of the boys and 7 of the girls earned A's for their first semester. Okay, so your job right now is to try to figure out where those numbers go in the two-way table. If you're wrong, it's totally okay. We're just learning it. It's okay. You guys can talk about it. I don't need you to fill out the rest of the table right now. You're just, unless you want to, you can. You're just trying to figure out where the numbers go. Total. Okay, here is where the numbers go. My total was 145. There are 116 total boys, 29 total girls. 24 boys have A's, 7 girls have A's. Okay, so that's the setup from the problem. What do I do to fill out the rest of the table? Okay, so 24 plus 7 is 31. So this total with A's is 31. What else can I do? 116 minus 24, so there's 92 boys that don't have A's. 22 girls that don't have A's. And then how many total students don't have A's? 114. Beautiful. Okay. Now we're going to find the probability that a boy has an A. So I'm going to take my Post-it note and I'm going to narrow my table down to just the boys. I'm only looking at the boys. Yeah, how many boys have A's? 24. And how many total boys? 21%. Beautiful. Yes, honey. Yeah. So it kind of depends on the way the question is asked, but either one of these is fine if it doesn't say. Just have one or the other. On the AP Stats exam, you're allowed to just write the 24 over 116 because you found it technically. Okay, girls with an A. So I scooch my Post-it note over. That would be what out of what? 7 out of 29. You're getting the hang of it. Okay, now you guys notice there's another table, last one. This is the last thing of the day. If you guys could please draw this last one for me. I'm almost there. So far, because you have third period next. I have two more math, 3 classes to teach after this. I have one for you. You guys are so cute up there. Okay, last thing. This is called a conditional relative frequency table. Isn't that fancy? Okay, so this problem is called a two-way table. And this is called a conditional relative frequency table. A conditional relative frequency table takes the answers that we got from this and organizes them. So in this box, we would put 24 over 116, which is this box over the total, which we already said was 0.21. In this box, we would put 7 over 29, which is 0.24. Okay, now what do you think would be in this box? Yes. Okay, you're 100% correct. I'm going to write it like this. But what Landon is saying is, Mrs. Talbot, don't bother to do this math. Just do 1 minus 0.21. By the way, in AP Stats, that's called the complement. The complement means everything else. And this would be 22 over 29, which is 0.76. Okay. What does this allow us to do? It allows us to compare the two variables to see if they're related in any way. If these were matching across, you could tell that they were not, there was the same probability of it happening, so they were not associated with each other. Do you guys notice that the girls have a little bit more percentage of A's than boys? Just a little bit. Okay, so we would call this weakly associated. And we would say, this is the last one we're gonna write. Gender and having an A are weakly associated. What type of table? I don't remember, but you just have to divide. Do you know where I got the numbers from? Yeah. Well, if it asks you for it, I don't remember is the answer to your question. I don't remember. But I will look for you. Now, if you could look at the camp sheet side real quick. So you see the homework there. I want you to notice two things. There's no quiz for this chapter. And also the chapter 10 test and final exam are the same test. I just squish them together so you don't have to do two separate ones. You guys really strong.
Yeah.
Does that make sense? So just like last semester, it's just one test that covers the final and chapter 10. And I'll have more information about that later.